When you click the link above the screencast, it'll bring you to this leverage point exploration using Desmos. Notice you'll see here that there's a scatter plot with a strong positive linear association. Okay? And I also have the least squares regression line right on the screen for you. You want to mention to your students the slope and the y-intercept, and also the correlation and the coefficient of determination. And you definitely want to talk about those things. Might be a good idea for the students to write them down. Now I want to show you what happens when we have a leverage point and how the leverage point affects the least squares regression line. So what you're going to do is you want to shut this line off, okay, and add the table with the leverage point. Okay. So the dots changed to red, but I'm going to shut off the green dots. Okay. And you can see that I now have the same scatter plot, but I have this leverage point out here. Okay. You want to explain to your students what a leverage point is, an outlier in the x direction, and then we're going to go through influential and non-influential leverage points. Okay. If you click over here, you can put the new least squares regression line on the screen, and then you should compare the correlations and the coefficient of determination. Notice how with the addition of 1 point, the correlation increased from 0.933 to 0.98. Okay. That's important, that 1 point kind of helps to overemphasize the relationship between the two variables. Okay. Notice how the slope and the y-intercept from the green line here without the leverage point and now including the leverage point have changed very slightly. Okay, just a very minor change between the slope and the y-intercept, and that's why you want to explain to your students that this point is called a non-influential point, because it barely influenced the slope and the y-intercept of the regression line. Now what you can do is take the leverage point and move it. Okay, we're allowed to move it up and down. I'm going to move it down here. Okay, take a look at what happens to the line. Okay, notice that the slope is decreasing, the y-intercept is increasing, but more importantly, the correlation is decreasing, and also the coefficient of determination, how well the line fits the model, is decreasing. What happens? What does that mean? It now means that your regression line will make inaccurate predictions, and you can clearly see that this line does not fit the overall pattern of the scatter plot. And the reason it doesn't is because of this influential leverage point. The line is following it. Okay? Because it's an outlier in the x direction, wherever I move this point, the regression line is going to follow it. Okay? So you really want to make sure you explain to your students that it's important to report the statistics without the outlier, okay, which is this green model, and report the statistics with the outlier. Okay? You want to make sure that you report both. Okay? Now if you click the undo button, it's going to put the leverage point back in its original position, and then you could show the students how it would be a good idea to make a prediction without the leverage point and just go back to the original. So all I did was turn on my green line and turn on the table without the leverage point. Okay. So you'd want to report these statistics, and then also you can report the statistics, which are down here. This is the red line, when the outlier is also present.